Next, let's look at about profit, marginal profit, and maximum profit. So here we have profit. A profit function is derived from the difference between the total revenue function Rx and total cost function Cx, denoted by total profit equals to total revenue minus total cost. So the function will be pi x equals to Rx minus Cx. So here we represent profit function as pi x. Next, we also have marginal profit. Marginal profit function represent as pi prime x equals to the first derivative of profit function, which is pi x. The marginal profit can be interpreted as the extra profit earned from an extra unit produced and sold at units of production X. So here we also have maximum profit by using second derivative test. In order to maximize profit at the level of production X0, the following conditions must be satisfied, which is you need to satisfy the first one, pi prime X0 equals to 0, and also pi double prime X0 less than 0. This is to find the production level. So the second derivative less than 0, it's shown that we are going to have the set phase, means that this is the maximum. Therefore, it's obey the statement where we need to maximize the profit. So, the maximum profit is given by pi x0 and its unit selling price to obtain the maximum profit is px0, where we have px equals to rx over x. So now, let's look at example regarding profit.
Example 3. The revenue function in RM for selling X kg of butter cake is given by Rx equals to 30x minus x square. The total cost to produce X kg of butter cake is given by the cost function Cx equals to 10x plus 20. Find the demand function and the profit function. Write the function given, so revenue function and cost function. First, you want to find the demand function. Demand function is actually your price function. Okay, we can find the price function by using revenue function. Revenue function is price multiplied with quantity. So because we want to find the price function, so your price or your PX equals to revenue divided with quantity. Okay, for this question is X. So take the revenue function 30x minus x square all over with x. Simplify each term. So your PX is equals to 30 minus x. Then let's proceed to find the profit function. Okay, profit function is equals to revenue function minus with cost function. So substitute the function into the formula. So Rx equals to 30x minus x square, and your cost function is 10x plus 20. Simplify all the terms. So you should get 20x minus x square minus 20. So this is your profit function. The demand for an item produced by Delta Sdn Bhd is given by P plus 0.2x equals to 100. Okay, where P is the price per unit and S is the quantity demand. The total cost Cx, okay, of producing X unit of the item is given by 800 plus 30x when X is the level of output. Okay, A, find the total revenue function. B, the total profit function, and C, the total profit when 100 units are sold. We can find the total revenue function, okay, by using formula Rx equals to price multiplied with quantity. Okay, from the formula, we want to use the price function. Okay, the question give you P plus 0.2x, okay, equals to 100. So we want to, okay, to take the P as your subject matter to get the price function. So P equals to 100 minus 0.2x. This is your price function. Okay, let's proceed to the revenue. So your Rx equals to, your price function is 100 minus 0.2x multiplied with your quantity, okay, is x. Expand the terms 100x minus 0.2 x square, okay, for revenue function. Okay, for profit function, we can get it by taking your revenue function, then minus with cost function. Revenue function, you can take it from A, 100x minus 0.2x square, minus cost function is already given, 800 plus 30x. Simplify all the terms. Okay, so you should get 70x minus 0.2x square minus 800. For C, you want to know the total profit when 100 units are sold. So 100 unit is X. Okay, is X. So we substitute the values into profit function. Okay, we take the function from B, 70. Okay, X is 100 minus 0.2 times 100 square minus 800. Okay, calculate the values, 4,200. The conclusion, which unit? Total profit, okay, when 100 units are sold is RM 4,200. Example 5. The revenue and the cost function in RM of a product are given as Rx equals to 600x minus x square and Cx equals to 200 plus 6x plus 2x square. For A, find the profit function, hence determine the quantity to maximize the profit. And for B, okay, currently the company is producing 100 units of the product. Should the company increase or decrease production? Okay, for A, to find the profit function, we use the formula revenue minus cost function. Both function is already given. 600x minus x square minus 200 plus 6x plus 2x square. Simplify all the terms. Okay, we should get 594x minus 3x square minus 200. Okay, after we get the profit function, okay, we want to determine the quantity to maximize the profit. Okay, to determine the quantity, okay, we find the marginal profit, okay, equals to 594 minus 6x. Okay, we take the marginal profit and equate with 0. 594 minus 6x equals to 0. Okay, we will get x equals to 99. Okay, don't forget to test your value with second order derivative test. Profit double prime is equals to negative 6. The value less than 0, that means it is a maximum. Proceed to the conclusion. The profit is maximum at production level of 99 units. Okay, after we get the quantity to maximize the profit, then we want to proceed for B. Okay, currently the company is producing 100 units of the product. Should the company increase or decrease production? So for this part, okay, we want to use the marginal profit. Okay, we already find it in A. Marginal profit is 594 minus 6x. Okay, we substitute the value of x equals to 100 into the marginal profit. Okay, we get negative 6. Okay, what is the conclusion? Increase or decrease? The company should decrease the production. Why? Because at production level of 100 unit, okay, the profit is decreasing because the value is negative. By how many? By 6 ringgit per unit. Okay, so that's why the company should decrease the production.